All right, so this question is asking us to find the molecular formula of the compound above. So the compound that we just found is C2H3NO4. If you did not see how I found this and you are so lost right now, you should go back and watch the video for station 2, number 3. Okay, so this criteria for success is telling me to determine the molar mass of the empirical formula. I know that this is my empirical formula because these ratios, 2 to 3 to 1 to 4, I cannot make these any smaller. So I have to find the molar mass of this whole thing. I know that there are 2 carbon atoms because the subscript 2. I know that there are 3 hydrogen atoms. There is just 1 nitrogen and there are 4 oxygen atoms. So if you look at the periodic table, the mass of carbon is 12.011 times 2 is 24.022. The mass of hydrogen is 1.008 times 3 is 3.024. The mass of nitrogen, just 1, is 14.007, and oxygen is 15.999 times 4 is 63.996. So I'm almost done with this molar mass. I just have to add all of these numbers together. So 63.996 plus 14.007 plus 3.024 plus 24.022 is equal to a grand total of 105.049. And this is a molar mass, so my units are grams per mole. Alrighty, so I determined the molar mass of the empirical formula. Check. Determine the ratio of the molecular formula's molar mass to the empirical formula's molar mass. So I need to use this equation. The molar mass of my compound, which they give me in this problem, the molar mass of the compound is right here. This is the sample that they have. So 210.108. And I have to divide that by the molar mass of my empirical compound, which I found right here. 210.108 divided by 105.049. If I divide that, 210.108 divided by 105.049, that is approximately 2.0, that is 2. So multiply the empirical formula by this ratio. So I have to go in and multiply every single subscript by the ratio that I just found. So that means that my final formula, I'm going to write it again right here, I have a carbon, I have hydrogen, I have nitrogen, and I have oxygen. I have to multiply 2 times 2 for carbon. That means I have 4. 2 times 2. 2 times 3 for hydrogen. 2 times 3 is 6. 2 times 1 for nitrogen, that is 2. And 2 times 4 for oxygen, that is 8. And that is my molecular formula.